let's look at a rule where we only have two items. We have an item on the left-hand side, and then we have an arrow, and then we have an item on the right-hand side. And so let's say an association rule with respect to buying chips on the left-hand side and buying beer on the right-hand side. Now, he does introduce a couple of additional terms here that are useful. The left-hand side is the antecedent. Can you see the arrow right here? I copied it right out. It looks like. So chips are the antecedent. Beer is the consequent. This symbol, the arrow, just means is related to. They coincide. Okay, so it's just an arrow going from the left to the right. Now, a couple of things about these rules. I believe exclusively on the right-hand side, you only have one item. You don't have combinations of items. I believe that's correct. But on the left-hand side, you can have any number of items. So you can examine the combinations of things, a set that is the antecedent, which result in, the consequent, which is one item. Okay, so we get into conditional probability. What we're looking at here is you want to know if somebody buys this, if somebody buys chips, what's the relationship between that and the probability that they buy the consequent, they buy beer? Well, there are a number of ways we can look at this with I guess it's Bayesian conditional probability. This is the symbol for the probability that they buy this one, the consequent, given the straight arrow, the straight line up and down means given that they buy A. So the conditional probability of buying B, given that they buy this thing. And probability, in the study of probability, what that works out to mathematically, it is equal to the probability that they buy A and B divided by the probability that they buy A. That's what you're talking about. You want to know the conditional probability they buy A given they buy B. I'm sorry, you want to know the conditional probability they buy B given that they buy A. Well, that's what it is. Okay, so this is the confidence. This is the measure of confidence. And it reflects, it's a percentage from 0 to 1, and it reflects the proportion of times that B is bought given A is bought. That the consequent, it reflects the proportion of times that the consequent is bought given that the antecedent is bought. Now, lift, on the other hand, here's our little arrow friend again. Lift is what lift is. Lift is the measure of confidence. That is, it is the ratio of confidence divided by the number of times that B is purchased. So what this says is you want to know what confidence measures. A confidence measure of 1 means that the association of buying B given that they bought A is no greater than just the probability of them buying B. So, or said a different way, you get no more information about them purchasing B given that they bought A compared to just transactions where they bought B. If the ratio, because that's a ratio of 1, the conditional probability of B given they bought A divided by the probability of B, that's a lift of 1. Now, if it's higher than 1, that means that when they buy A, you have more information. There's a greater likelihood that they will buy B as compared to all transactions in which they just buy B. So lift is a measure of you could think of it as the increased probability of them buying B given that they buy A. A lift of 1 means knowing that they bought A doesn't tell you anything at all. Okay, so you want high lift. You want to determine rules. Each rule, we determine a set of rules, which are the frequencies of the associations in the entire transaction list between the antecedents and the consequence, and you want to identify those rules that have a high lift, because that tells you if they buy the antecedent, it's much more likely, there's a greater increase in the probability that they're going to buy the consequent. Okay, so lift is important. You want high lift, and gives us some calculations, ratios, how you can compute this. It's the support. Now we can skip all this. It's the support. Remember, support is just the support of the left-hand side and the right-hand side is just the number of transactions in which they both occur. So lift, it can be calculated manually as the ratio between the number of transactions in which the left and the right both occur divided by the number in which the left occurs times the number in which the right occurs. Or I should say the proportion. Okay, so you want the antecedents that have big lifts give you actionable knowledge about the consequence. And so that's what you want. Now, you can determine, you can compute confidence and lift quite easily. As we can see from these strict ratios, you can just use support measures, which are just proportions, to determine them. And you can also determine support relatively easy if you only have one item on the left-hand side and one item on the right-hand side. But the difficulty or the expense to computation comes when you have multiple items as the antecedent, because it requires that you calculate the coincidence of pairs. So if you have 9 antecedents, you have to get the support measures, you have to calculate the coincidence of pairs of those items, as well as the entire set, and it's quite computationally expensive.